We're going to continue on with the lesson on section 8.1 on counting principles, multiplication rule, and permutations. And we're now at part B of the question regarding the number of distinguishable permutations of the letters in each word. And we're looking at repetition as well. So this word is Hollywood. HOLLYWOOD. All right. And so now we're going to say the cardinality of that Hollywood. And we're going to find out that it has 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 letters is our cardinality. And then we need the repetitions. For this 9-letter word. All right. O's, we have 3. 1, 2, 3. L's, we have 1, 2. Y is 1, W, D, H. And those are the 2 repetitions we have. Okay. So now we're going to construct our problem. All right. So we know we have 9 permutations of 9 over. Then we're going to divide by, and this is interesting too, we have 3 factorial and 2 factorial. And we're going to do it by calculator. And we're going to put this in parentheses because it is a denominator. So let's talk about that. This could be an interesting problem. 9, math, P-R-O-B, we're doing number 2, and we're entering 9. Number 2, sorry. And we're, 9. Sorry about that. Now a side arrow to make sure I'm online, and then I'm going to hit divide, open parentheses, 3, math, P-R-O-B, number 4. And then I'm going to say, I can put it times or not put it times. It will do multiplication, but I'm going to put it times. And then I'm going to write 2, math, P-R-O-B, factorial, and close parenthesis. So I have what I need, and hopefully I get a good answer. So this is my answer. Let me move this over here for a little bit. 3240. All right, so we have this many ways to do Hollywood. And, you know, just for sake of how much it affected it, I'm going to delete going backwards. And just make it a permutation of 9. Choose 9. Okay, so I'm going to enter. Look how big it would have been, 364,880 if all the letters were different. All right, so now we're at the last one, and it is referred. R-E-F-E-R-R-E-D. All right, so the cardinality of R-E-F-E-R-R-E-D is 1, 2, 3, 4, 5, 6, 7, 8. All right, repetitions are Okay, so we have an R. 1, 2, 3. And then we have E's. 1, 2, 3. And then we have R's, E's, F, only one, and D, only one. So those are them. So now we're going to construct the problem. Oops, sorry about that. There we go. Let's construct the problem. So we have a permutation of 8p8 over, in parentheses, 3 factorial and 3 factorial. All right. So we're going to get our calculator out. And I'm going to place that in there. 8, math, P-R-O-B. And we're going to do number 2 and do 8. We're going to hit divide. We're going to open parentheses. Open parentheses is the number, is above the number of keys. Open oops, oh, what did I forget? Oh yeah, I forgot to do the side arrow to make it come up. And I'm going to hit, ooh, that's terrible. Let me go back. I have to delete that one. Almost made a mistake, sorry about that. I'm going to hit divide and open parenthesis, and we're going to put 3 factorial times 3 factorial. Close my parenthesis, looking super, enter. 1, 1, 2, 0. And that's with repeating letters. All right, we've learned a lot. Absolutely learned a lot. So let's see where we're at. We're at this question here. Kristen's financial advisor has given her a list of 8 potential investors. All right. And has asked us to select and rank. Rank meaning order specific. So we're going to use a permutation. All right, now we justified what we're going to use. Her favorite 4. So my R is choices. How many ways can she do this? Well, we're going to do a permutation. 8p4. Now remember, the book uses the capital P parenthesis N R. But this is better for us because we enter it in the calculator in that form. So we have it ready for that action. Okay. I'm going to enter the 8, math, P-R-O-B. I'm going to go number 2, and then I'm going to enter the 4, side arrow, and enter. And I'm going to have how many ways? 1,680 ways to select 4. It's by ranking. Right. Right. Here's our last question. Aren't you glad? Now you hope you've been making notes because I follow your homework very carefully. On a ballot, the candidates for each office are listed together under the office for which they are running. In an election of 3 candidates for one office and 4 candidates for another office, how many different versions of the ballot are offered? So in this one, it's a culmination of everything we learned. We're going to have the permutation capabilities and times and permutation for the second candidate. All right, so let's write our permutations. We're getting 1. So we're going to have 3P1 times 4P1, because the other one has 4 for another office. So that's what we're going to do on our calculator. So we're doing the multiplication rule after we do the permutations. So let me take a screenshot of that. Let me stick it up here someplace. Just give me a second. But you can see you all can see the calculator stuff on my notes. Oops, I was drawing it down and it didn't happen. There we go. So, and I'm going to do that on my calculator. Let me clear this and I'll enter the 3. Well, what is it? It's 12, isn't it? 3 ways for the first one and 4 on the second one, but we're going to do it just to make sure. I'll do 1. And sure enough, so this is going to be a 3 times a 4, 12 ways. For this action. All right. Now I need you to have written some notes and work things out carefully to understand everything we've done. And look at the notes if you need to. Do your homework.